This week on Maker Update, retro future perfect computing that never was, a Need for Speed mini-map for your car, a robot made of phone parts, and the glorious use of LED acrylic. Hello and welcome back to Maker Update, the show where we find the best projects that makers are making and share them with you so we can all get inspired and learn together. I'm Tyler Weingartner, the snow is falling, and I hope you're all doing great. We've got a wonderful show for you, so let's get started with the project of the week. There's just something incredibly satisfying about old computer hardware. It's big, it's clunky, and it's chunky. It feels like a throwback to hardware-driven machines like electric or even manual typewriters. The nostalgia around old computers like the Commodore 64 is incredibly strong because for a number of people, this was their introduction to computing. Which is why Kevin Noki is making the Commodore that never was, the Commodore 64 laptop. He begins by designing and printing the external enclosure. And he's bringing as many of the design cues from the C64 as he can. The layout, the key shapes, placement of ports, vents, everything. There's also a bit of a nod here to the original Macintosh Portable. He also adds a great tip for printing objects large enough that they won't fit onto your print bed. He's modeled a series of registration holes where the large parts are supposed to come together, and using small metal dowels to keep everything aligned during the glue up. With everything assembled, he can move on to sanding and priming. And finally, painting the external body parts with a custom color that matches the original article. The keyboard keys also deserve a special mention. They're 3D printed as well, and the labeling is done via water slide decals. To make sure the labeling is the right color, Kevin made his own custom white toner cartridge for his laser printer just to print the labels. The brains of the C64 laptop is a Raspberry Pi 5 running an emulator for the Commodore environment. He also wants to preserve as much as he can of the connectivity of the original Commodore 64 in this build. From the classic 9-pin serial ports to connect peripherals like joysticks, and even these round DIN ports for connecting peripherals like disk drives and even tape drives. Each of these are all managed by their own individual microcontroller before passing the data onto the Pi. There's also a little bit of space left on the enclosure in case he ever wants to add the cartridge reader. It takes a huge amount of work to commit to a bit. He's adding a brightness dial for the display and modifying the display's firmware to get rid of the HDMI status displays. The attention to detail on display here goes so far beyond any traditional cyberdeck build, and it elevates this into something like replica prop or cosplay. But it all still works, just like you'd expect a 43-year-old computer to run. He even boots up his ancient floppy disk copy of Pac-Man. It's incredible. Check out the whole build by following the link down in the description. More projects. Speaking of committing to a bit, Garage Engineering recently released this project where he's adding a video game-inspired mini-map display to his car that updates as he drives. And the particular video game mini-map he wants to emulate is from Need for Speed Underground 2. The brains of this car mod is a Waveshare ESP32 S3 with attached circular touchscreen. He's not streaming in the map data though. Everything is preloaded using map tiles from a service called QGIS. With all the map tiles added, he's then able to begin styling all of them so they look like the interface from the game, and also adding in his own points of interest. Petrol stations, parking lots, airports, service stations, that sort of stuff. After getting the whole dataset loaded onto an SD card, he's got it paired up with coordinates from a GPS sensor, and it all comes together exactly the way he wants. But because all the map stylings happen under his control, you can easily modify them to represent other games. Red Dead Redemption, Grand Theft Auto, Cyberpunk, whatever you want to see on your own dash. To celebrate the second season of the Fallout television show, Tony from Dabbble has created this pocket toy diorama, reminiscent of the old kids' toys Polly Pocket or Mighty Max. The idea here is that you have a sculpted piece that folds open to reveal the small-scale diorama. The sculpt for the helmet that's used as the outer feature is created digitally in Nomad Sculpt, and then 3D printed using an FDM process. But for the diorama parts, she's sticking to her guns and making the walls from hand-cut mat board. What started out as a fairly process-driven project then goes completely free-form, as you get to see her sculpt and paint all the interior details with scenes from Vault 33 of the series. She then adds in a number of small 3D printed bits of furniture and characters. Lucy, the Ghoul, Maximus, and Dogmeat are all here. It's a super fun project on a tiny scale. Don't miss it. I'm always impressed when I see videos of crafters building intricate models from their hoard of scrap pieces, old food containers, chopped up models, and other things they have lying around. So with this video by Roborovski, turning an old desk phone into a robot using only the materials in the phone, now you have my attention. When these are all the parts you've got, your first step is to desolder the PCB for greeblies. Capacitors, ICs, anything that looks interesting. The handset enclosure becomes armor, the wiring becomes a coil for a future weapon, and everything gets used one way or another. It's an incredible journey of re-envisioning scrap into a whole new character. Time for some tips and tools. Wes from Geeksmithing has joined forces with friends When Geeks Craft to build a light-up display for his local Festival of Lights. The event itself is a wonderful parade of lit-up sculptures, but for Wes and crew, this journey takes them on a deep dive into black LED acrylic. Their goal here is to make what looks like three-dimensional pixels. With this setup of dividers printed in white PLA, they fell in love with the light bleed out the sides and how it created this weird cubic light-up pattern. They also experimented with different pixel shapes, using the acrylic for the sides. It's a great look at this fun material. Moving on from filling 3D prints with concrete, Chris Borge is now taking on the skill of using 3D printed forms to create metal casts. If you've ever wanted to try metal casting in sand, this is a fantastic video to start with. Unlike a lot of other videos out there, this one doesn't skip over all the things you're likely to do wrong if you're new at this. Sand composition, packing technique, you get to see all the starting mistakes laid bare without you having to make them yourself. It's a great video if you're interested in getting started with this process. If you're a big fan of printing in PLA because of its ease of use and reliability, check out this video by JanTec Industries about an alternate filament called PHA. It's more readily biodegradable than PLA, has better mechanical properties, and believe it or not, it's even easier to print because it doesn't absorb moisture. But it does have some trade-offs. First of all, the price. It's at least twice as expensive as PLA. But it also requires a post-curing time of around 48 hours for the plastics to crystallize and for parts to achieve their full strength. And from Daz Projects, we have a design for a shifter controller for sim racers that can be built for around €40. This is a clever design of 3D printed parts, metal rods, a short segment of linear bearing, and springs. The position of the shifter is determined by a series of limit switches, and the data is processed by an Arduino Leonardo, which is already being used to manage other control inputs like pedals. Cool stuff. For this week's DigiKey Spotlight, Zach, the bite-sized engineer, has a guide on using LiDAR for your projects. LiDAR is used by everything from self-driving cars to robot vacuum cleaners in your home, and they pretty much all use it for the same thing: detecting obstacles in the environment so it can avoid them. It does this all through a process called simultaneous localization and mapping, or SLAM. Zach demonstrates this with a fairly high-end LiDAR module, the RP LiDAR A1, and then he shows obstacle detection using the demo software. But then he goes on to show you how to integrate that data into your projects. Check it out. All right, and that is going to do it for this week's show. A reminder, as always, that you can find links to every project, tip, and tool by checking out the links down in the description. While you're there, leave us a comment, give us a thumbs up, and hit subscribe so you won't miss the next one. Huge thanks, as always, to DigiKey for making this show possible and to you for watching. Take care. We'll see you soon.